We have studied several nucleophiles over attacking over aldehydes and ketones. So hydrides, Grignard is another type of nucleophile, so carbon nucleophiles. And we have studied oxygen nucleophiles that you can do hydrates, hemiacetals, acetals. Now, sulfur is another type of nucleophile. And if you remember in your periodic table, here's oxygen, right under you have sulfur. So same number of valence electrons. The chemistry here is very similar. So sulfur nucleophiles, if you have here a ketone, and instead of using an alcohol, we're going to use a thiol. So as H instead of OH. And in that case, if we have an excess of that, say acidic conditions, we are going to form something very similar to the acetal, but this time it's called an thioacetal. Thioacetal. Very similar. Mechanistically speaking, it's the same. Under acidic conditions, you will protonate this, and then do the attack. It's a number of steps, but similar to what we did in the acetal formations. If you need to review that mechanism, I have a video on that. In the thioacetal will be the same. So you're forming an emi thioacetal, so intermediate. I have several steps here, and I will have OH, and here SR. So that's the emi, but it's thioacetal. And then I have more steps, and I get under acidic condition, the thioacetal. All right, it's not that different from acetal formation, but the application of that is we have something that we cannot do with acetals. So when we have ketones such as that, and then we use, instead of ethylene glycol, we use this thiol, dithiol. Reaction is very similar under acidic conditions. So I'm going to do the protonation step first. Let's do it right away. Acidic conditions. And then I have a nucleophilic attack over here. Steps. I'm going to have the emi thioacetal. This will have initially an S, and that is H. That is formal positive step. I will have a proton transfer step to have the emi, just as we did before. And then other steps. Again, look at the video of the acetal formation for the mechanism on that. And after that, I will have a cyclic thioacetal. Cyclic thioacetal. Very similar to the cyclic acetal, but what this is used for was different. We're going to use this reaction to actually remove a carbonyl group using a reducing agent. This is called Raney Nickel. And what this does, and I'm going to draw the mechanism, is simply remove the carbonyl altogether. So I started here. And so let's draw the steps. If I do this and do first reaction, the cyclic thioacetal formation, and then use Raney Nickel, I will obtain, this is nickel, so removing the carbonyl together. So very useful when we have synthesis strategies. We have several. We can do a Clemmensen reduction of aldehydes and ketones. We can do Wolff-Giffner, and this is the use with Raney Nickel through the thioacetal formation. We will apply that in sequence with synthesis, planning synthesis.